Hello everyone. We are given a stable, real linear time invariant system with a single pole at P and has a transfer function h of s equals s square plus 100 divided by s minus p. The DC gain is given to be 5. We have to find the smallest positive frequency in radians per second at unity gain. To know more on the concepts used to solve this problem, kindly refer the NPTEL Control Engineering course Week 6 Lecture 1 by Professor Ramkrishna Pasumarthy of IIT Madras. We'll be using the following concepts to solve this problem. The DC gain of a type 0 system is the ratio of the steady state value of the output of the system to a step input and the magnitude of the step input, and it can be found using the final value theorem. Also, the frequency response of the system can be obtained by setting S equals j omega and then computing the gain and the phase of the system as a function of the input frequency omega. Let us now start solving the problem. We are given h of s equals s square plus 100 divided by s minus p, and the DC gain of the system is given to be 5. Now the DC gain of a type 0 system can be calculated using limit s tending to 0 h of s equals the given value is 5. So we'll substitute h of s square plus 100 divided by s minus p equals to 5. Now when we calculate the limit, it will be 100 minus 100 divided by minus p equals 5, or p equals minus 20. So that is the value of p. Now we'll substitute this to h of s. H of s equals s square plus 100 divided by s minus and minus. So it will be plus 20. So the pole is at minus 20. Now we are asked to find the smallest positive frequency at which the system will have unity gain. So the magnitude of the system at unity gain has to be found. So we'll substitute s equals j omega. When we substitute s equals j omega, it will become magnitude of j omega square plus 100 divided by j omega plus 20 equals 1. Now this is magnitude of j omega square is nothing but minus omega square, since j square is minus 1. So it will be 100 minus omega square divided by j omega plus 20 equals 1. Will be equal to 100 minus omega square divided by the magnitude of the denominator will be root of 20 square plus omega square equals 1. Now we'll cross multiply and we'll get 100 minus omega square equals root of 20 square plus omega square. Now we'll square both the sides. Squaring both the sides, we'll get 100 minus omega square equals 400 plus omega square. Now we can simplify this to get omega raised to 4 minus 201 omega square plus 9600 equals 0. Now we can solve this equation, which is a quadratic in omega square, to get omega square equals 122.86 and 78.13. So this can be solved using the usual quadratic formula in omega square. So we'll be dropping this value. So we'll ignore this value since we have to find the smallest positive frequency, and 78.3 is the smaller of the two. So we'll proceed with 78.3. So we'll take omega square equals 78.313. Now omega will be equal to plus or minus 8.839. So we'll ignore the negative value since we only need the positive frequency. So finally omega equals 8.84. So we can approximate it to 8.84. So this is the frequency at which the system will have unity gain. Looking back at the options, we find that the correct option is option A, 8.84 radians per second. Thank you.